Does. Cool. So, welcome everybody. I'm Richard. I work for this company down there on the left, Myborn Wolf, and there I'm head of software archaeology. And I have a confession to make. This is my first time at JSHeroes. This is my first time in Romania. My first time. I have a couple of more. wait, you will notice where my sentence ends. Anyway, so first time in Romania, first time in Cluj. And it's also the first time my daughter and wife are watching me on stage at a conference, and they flew also all the way from Frankfurt here. Yes! Cool. So, let's go to the content. As head of software archaeology, I often do software modernizations, and a particular thing I like to call software archaeology. And during it's been a decade. During this decade, I discovered multiple techniques that work reliably enough that I think they're worth a talk. One of them is forensic techniques. So I have a bit more about other techniques, but this one's about forensic. And it's the original idea is by a guy called Adam Thornhill. Has anyone heard of Adam Thornhill? Okay, cool. So his name will come up, you will learn a bit about it, and afterwards I think you might want to buy his book because it's very incredible. So, not my idea, his. Now, how do we approach this? I think we should approach this with a story. And the story typically starts with a hero, an incredible hero. In this case, it's Alex. And Alex is great. Alex loves the job. But Alex also has a boss. And one day, Alex's boss comes along, and she's like, "You there. Phoenix is not making any sense. They are getting slower and slower." Yeah, the voice is that deep. "You are now in charge of it. Fix it." What is Phoenix? And she's already gone. Okay. Well, Phoenix is 50,000 lines. Where do I even start? And that goes back to the heart of the problem. If you buy a car and you take it apart, you actually know how the car looks inside. I mean, if you're a mechanic. For software, it's immaterial. You cannot touch it. It's not like a painting or a car or something like this. So, what can we do? I'll ask ESLint. And ESLint comes along and ESLint presents this. And it kind of feels like that. Right? It's like, oh great, I'm driving a car and everything is broken, thank you. Okay, but we have a new technology. What's the new technology? Okay, someone said very quietly AI, so yes. How about I ask Cloud Code? And the prompt is, what are the biggest issues of this code base, and in what priority should I fix them? I think that's okay. So Claude does some super advanced technical work. Claude uses grep. And I'm not kidding you. I put a proxy in between it. I checked what tools it actually executes. That's what it does. That's the Explorer agent. And one of them is select from where. So what does it do with all of that? It creates this report. And it says, okay, your main priority should be, within the next 30 days, security audit SQL queries. Which is a very useful thing to do. But then you ask yourself, okay, that's cool. But what happens if I do exactly the same question again? And they're just clear? What happens? It's like 30 seconds between these reports, right? Well, that's what you get. It's like, okay, so critical is still SQL injections, but before that, it's hard-coded Sentry. Who was from Sentry again? But logging is no longer mentioned. And patching Bootstrap apparently is no longer important. Okay, so let's do it again. Clear? And now SQL is gone. It's like, it's not even the main thing important, all right? It's cross-site scripting vulnerabilities. And I don't know, I don't like that. It's not very reliable. It's cool, it's very important information, but, you know, I kind of want to have something that's reliable where it's, well, typically I get the same answer. So, because it feels like that. Except I have this dice here. And it's like, oh yeah, maybe you should do SQL injections first. Okay, so here comes Alex. Now what? The reports have a lot of ideas. So along comes Taylor. And Taylor's like, be careful about the voice, I worked a lot on this one. Have you tried software forensics? Oh, what is that? Software forensics. I will point him out again. Written by Adam Thornhill. Adam Thornhill is very, very special. He has 2 degrees. He has one in computer science and he has another one in psychology. So during his studies in psychology, he discovered that you can apply very similar techniques that you use to find offenders to code bases, because they're both very open-ended questions. So, software forensics, noun. Applying techniques inspired by forensic psychology, in particular geographical offender profiling, to software systems. Okay, how does it translate to software? Well, you apply temporal, social, and static metrics. Temporal would be commits, social would be authors, and, well, code would be your static data, no? The ESLint stuff, for example. And from that, you can uncover hotspots, uncover hidden dependencies, and reveal organizational friction. Now, that sounds very interesting. But isn't that exactly what ESLint does? ESLint is a source for static analysis. What we want is to correlate multiple sources on a map to find murderers. Can you even understand this? I hope so. Wait, what? Murderers? Oh, more correct would be offenders. Let me explain. So, I haven't studied psychology, so this is my very poor attempt at translating the concept. But the idea is simple. You have a map, you put a spot with one dimension. If you take multiple dimensions, you get this nice Venn diagram, and, well, there's your problem, right? So multiple dimensions that you correlate. And this is the start, how that can look. You take a 3D map, and you put the lines of code, you put, there we go, on the area. You know? So the more lines of code, the bigger. The tool I'm using here is called CodeCarta. It's developed by my company, but it's free, it's open source, and all data stays local, and by the way, you can use it for commercial or private places or whatever. So that's why I prefer using it, because I'm familiar with it. I've already mentioned there's other tools like CodeScene from the original author, right? So anyway, continuing with CodeCarta. So now you can already see a couple of things. For example, you can see the distribution, because the folders also grow with the amount of code inside of them. Yeah? If you have a larger file which has more lines of code, if you have 10 files with lots of lines of code, for example, a ribbon bar, it grows larger and larger, right? So, a bit of distribution. Now we can put another dimension on there. We can put the height on there. And on the height, we now put cyclomatic complexity. Anyone knows what cyclomatic complexity is? Yeah. Well, how many branches? So, any branch in control flow is a +1. So an if statement is a +1, a catch is a +1, a while is a +1, a for is a +1, right? So that's not the most perfect metric, but what it roughly tells you is where a lot of decisions are made. And where are lots of decisions made? Business code. And now you can put a third metric on there. For example, we put the smells that Claude has identified. And now we can already see, okay, we have 3 metrics. Now we can correlate. Correlate. And we can see, well, this is business model.ts. It's got lots of code. Many decisions and lots of smells. Smells like, well, there we have them again, the fix me's, the select, insert, whatever, right? Okay, that's the basics. So I guess I'll fix the complex and smelly code now. Complex code by itself is not bad. Add the temporal dimension to get true insights. Complex code that is changing all the time? Yes, changes in complex code are much more risky and expensive. And jokes aside, that makes sense, right? If you have to read a nested if and a nested if and a nested if and a nested while loop, and you want to make a change there, you have to think a lot longer about it, and you will probably make a mistake. So, here's how that looks like if we add a new metric. And this metric is very, very interesting. It's called churn. Churn is simply how many lines were added or removed, and you just sum that up. And now, this is the temporal dimension, because this tells you, down on the right, down up there, you have the model service, which has got lots of code, many decisions, and it changes all the time. So this piece of there, which the intention hiding name, is your prime hotspot. Because any change you make up there is probably super, super expensive, or a lot more expensive than changes somewhere else. And since we are at the frontend conference, how about we also translate this to our dear friend, the components? Let's say we're looking for complex components that are changing all the time, which are these. There might be multiple reasons for it. Maybe we have a design instability, so some UX issue in there that makes us change components all the time. Maybe the requirements are shifting all the time. And all of these are like triggers. They're not necessarily mean this is bad, but it means I should definitely look at this and figure out, do we have a larger problem there? So is it actually better? Is it better than this one-dimensional list that we had before? And I think it is, because they have a huge benefit, or multiple actually. One of them is, again, this 3 dimensions we can correlate. Next one is, we can see the forest and the trees. And this is like, I love this. I have a map and I can be like, okay, I can see individual spots, but can also see if they cluster in a specific area. I can explore and drill down when I see something and be like, oh, okay, I want to look at this, I want to look at this. It allows me, at least, to analyze and reason about large amounts of code, which is why we developed the tool, because when someone asks you, hey, within 3 weeks, can you tell us what is wrong about our code base? And it's 1 million lines of code, I cannot read it that fast. And I can show the state to stakeholders and experts alike. And we can talk about it. We can say like, oh, okay, why is this thing red and high and large? And just for funsies, we can 3D print it. Right? And you're all laughing because it's such a silly example, but it's now graspable code. Actually, we give them out at the end of our health checks. And customers usually love them. Now, this is where Alex started, and this is a very, very true story, and you can read about it on the blog down there. And this is where it started, and after about a year, it went to that. And that is something we can show stakeholders as well. You know, make it clear we have actually improved. So, we improved names, added tests, reduced nesting, and split up the remaining complexity in the hotspots. The team can work much faster now. But I have a bad feeling about this. You there! You are now in charge of scaling, Phoenix. Scaling? You mean add more people? And she's gone. Anyone has such a boss, by the way? I never had such a boss, but at the customer, it was really a person that just came in, shouted something to the room, and just went. And after about 2 weeks of this, I finally asked who was this person. Yeah, it was their boss. Now, what what a nightmare. Onboarding always takes forever. And yes, I know onboarding is much more than how the code looks, but we're talking about code right now, so let's stick to that topic. One of the things we can look at is now we can take another metric. We can take the number of authors, and we can create this. And this roughly tells us knowledge silos, because if we have one author for a file, then that is definitely Brent's code. I'm not cheating on Brent, but had anyone read the Phoenix Project? Yeah, okay, then you might know the reference. And down there we have another problem. This is Claude's code. And you can sort of see how in some companies this sort of spreads, and it's now just one author for everything, and none of them are in your team. And the interesting part is not just which file has one author, meaning only one, roughly meaning only one person knows about this. It also means, is this person still on your team? Right? Obviously, there's, it's metrics, so there's some tricky bits here, right? If you're doing lots of pair programming, it might still be one author. I encourage you to use the co-authored by trailer for this, in this case. Just because it's nice to say, hey, I worked on this with someone else, and also because it makes your tools more aware. But there are much more things that can make onboarding tricky. And these are specifically like situations where experts know, okay, this file has to change together with this other file, or that file has to change together with that, and so on. So there's this sort of invisible coupling. And the question is, can we make the invisible coupling obvious? And now, Adam Thornhill again. Adam Thornhill had an idea, and he called it change coupling. And the idea was very, very simple. I will look if certain files are always, or reasonably often, are committed together with other files. Then there might be a change coupling between them. No? I have to change them together. And of course, I can visualize this. Right? I can notice that rent component.ts is always changed together with all these other files, or reasonably often that there might be something between them. And notice there's no compile tab relationship. So it's not that there's an import statement. It's just, it shows up in the same commits reasonably often that something that is not modeled is between these files. Something only experts know about, or sometimes even not even them. So what is the cause of this change coupling? Well, usually it starts simple. We just simply copy and paste, right? And then we realize, oh, okay, this copy now has to stay in sync with the original one. And that's kind of a problem of duplicated knowledge, that the same thing has to be true in both things. The knowledge has to be true in both things. And then, of course, the result would be, hey, we should refactor towards spot, single point of truth. If you don't know that moniker, it's principally the same as dry. I just think it brings across the intention more than dry, because it's not about not repeating yourself, it's about this having... You should all refactor towards spot. Ah, okay. Thank you so much in the back. Okay, so we started pairing to share. We grouped things cohesively, added abstractions where necessary. Everywhere? No, only where changes needed to happen. But then we made mistakes. We couldn't keep it all in our head. Well, you could define your architecture rules as code. Anyone does that? Oh, yes, okay, cool. Now, everyone else, please pay attention, because this might be my favorite part of this talk, not the most important one, but the favorite one. So, there's a tool, and there are many others, but this is called Dependency Cruiser. And I can say that no code outside may access renting. So, I say from anything that is not source renting should not depend on source renting. That is a rule. that is a rule that it should check, and it should throw errors when this rule is no longer valid, because I want renting to be independent. Now, if you add these rules late to a code base, you will have lots of violations of this, and that is also not very helpful. So, how to fix that? Well, you define known violations. You say, okay, well, in this case, some other component, some service TS, is allowed to touch renting service. And then you store that in the JSON file as known violations, and now you continuously check. So every time it runs in the pipeline, it checks that all your intended architecture rules are still valid, and nothing new can be added to this. Right? So because you said, okay, these are my known violations, they are allowed, but nothing new can come to this. So this one is already very, very good, but now you need to do another step. Now you need to also check your known violations periodically and figure out, can I maybe reduce them on time, on budget? And again, I'm encouraging you to use a map for that, because you can you can put the architecture violations now on height and on color, and you can see, oh, well, I have certain areas in my code base that have more architecture violations than others, and your PO now goes to you and says, oh, yeah, I want a new feature, and you're like, yeah, that's in that part of the code base, it might take longer. And you can and that you can use as information to not only communicate the problem, but also to progressively fix the problem and maybe even preparatorily fix the problem before it becomes a problem. You there! Just in case you were sleeping. You there! Everything seems to be running smoothly. What did you do? Well, we reduced complexity in key areas, improved test coverage, decoupled modules, and I don't see anything in that. Well, you can see the effects in our delivery, but I could also show you a map. And it goes from the left all the way to the right, and it continuously becomes better and more graspable to stakeholders what the state of the code base is. You there. Unicorn is not making any sense. They're getting slower and slower. You are now in charge of it. Fix it. Sure. And gone. Now, in case you're interested in forensics, what was it? I think Dan was it yesterday. Sorry, Daniel had an idea, and I want to put this idea to you because CodeKata right now has about 800 downloads per week, so it's a bit less than 10-stack query. And I would hope you could, if you find it interesting, you know, I'm not forcing it, but if you find it interesting, maybe you could give CodeKata a star. Maybe you could even give it a PR or something like this, because I hope the community, you, might adopt this tool and it might help you in your endeavors the same way it has helped me or my customers. And if you want to read a bit more about this, you could also read about our experience report. Sorry, is the QR code not working? Hope it is. Maybe I'm standing in the way. Okay. And now, I actually have left time for questions. And if you want to talk to me about software archaeology or anything, you can always drink a physical coffee here or a virtual one with me. And I don't know if anyone has questions. I have some backup slides, don't worry, but I also have about 6 minutes for questions. Oh, all the way in the back.
Can I use it for absolutely anything? Can I visualize anything based on what I know about the code from elsewhere?
Yeah.
How much work do you need to put into integrating that?
Okay, so the question was, can I use it for absolutely anything? And the answer, the short answer is yes. The long answer is it depends on what you want to do. The license is BSD3, so there's no problem there. I will quickly go into how to set it up. I'm sorry about this. It's the analysis part. The visualization is the TypeScript application, Angular plus TypeScript. But the analysis part that does all this analysis stuff, it's actually written in Kotlin. And it's distributed via NPM. There's a reason for it. Java doesn't provide a way, but anyway. So you clone your project, and then we have a unified parser. Right? So if you install that, you have that. And it has many different parsers. It's pipes and filters architecture. So you use the unified parser, which can parse, well, not every code, but a lot of them, because we are building. Has anyone heard of TreeSitter? Yeah. So TreeSitter is GitHub's parse almost anything framework, and it provides lots of language bindings, and one of them, and we use them for the unified parser. So this one should parse most of your code base. And then it will generate this file, phoenix.uni, and this one you can now open in the visualization. Right? You can also open it as a standalone if you want to, but you can open this, and it all because it's hosted on GitHub Pages, so there's no backend. Don't worry. It just runs in your own machine, and you just open the file. Now, the file format is a very simple key-value pair, so you can visualize almost anything with that. And you can even extend it with the gitlog parser, which takes the git metrics. You can extend it, and you can merge it together, and then you can visualize this file. So that's the way you get multiple metrics in the same file. And one of the key things we have is a CSV importer. And because most metrics are just file path, metric. That's why you can visualize almost anything. For example, you can visualize your performance. On the height, you can put the total time the processor spent there, and on the color, you can put the CPU time. And that way, you see, oh, here it's spending a lot of time, but no CPU time, meaning it's waiting. And there, it's spending a lot of, not spending a lot of time, but almost all of that is CPU time. So you get like a different visualization that the flame graph would give you. And to give you your answer finally, if you can press it into a format that says file path, hierarchical, and metric, then you can visualize it. I've used it, for example, to compare performance tests. Right? So one performance test, which has about 1,000 tests, compared to another performance test, and then it gives me the delta. Did I answer your question? I don't know. Anyone else has a question? Then you have the follow-up. Yeah, you can apply it to dependencies. It depends on what you want. So I showed you how we visualize change coupling, and that has limits, I think. So which is why, so just from the 3D map with arrows perspective. So if you want more power there, we have another tool, which is called on the left Depender Carter. The alternative is, for example, Sonograph. And Depender Carter is not part of this talk because I cut it out. But the idea is very, very simple, similar to Code Carter. It's just focused on the dependencies between files, the import statements we until now didn't look at. And it just extracts all the import statements and then sorts all the packages by a heuristic, and the stuff that has only outgoing is on top, and all the stuff that has only ingoing dependencies is at the bottom, and that gives us huge benefit because that means we get this implicit ordering from top to bottom, and that means we can filter out these dependencies and these errors and don't show them because they're implicit, and instead we can draw all the dependencies that go up, meaning the dependencies we don't want to have. And now we can focus on that. Did that answer your question? Yeah. 25 seconds. Any other question? Okay. Is anyone impressed I stayed in time and in budget?